First step here is to realize it's a polynomial equation because we have a square, a first power, and a constant. So what we're going to do is we are going to start by moving everything over to one side. So it's polynomial, and anytime you have a polynomial equation, you want to get it equal to 0 and then factor and then set those factors equal to 0. So if I move everything over to one side, again, here is my equal sign. That splits us up into two sides. I'm going to move this 11z to the left-hand side. Now, currently, the sign that is in front of the 11z is understood to be a plus. So to undo that plus 11z, I'm going to have to subtract 11z from both sides. So that will give us z squared minus 11z plus 10 equals, and then on the right hand side, these z's cancel to 0. Now, I was kind of sneaky about that because I just kind of wrote it as z squared minus 11z plus 10. But you'll notice here that I arranged this from the highest power all the way down to the lowest power, or the constant. So it goes z squared, z to the first, and then the constant. And you always want to do that just so that your work is organized. So it's very important. We're going to go highest power all the way down to the constant. We have this equation. Now, once we move it, then we are going to factor. And when you look at factoring this, you'll say to yourself, okay, is there a GCF? And in this case, there isn't. So then you'll think about the factors of the first times the last that sum up to the middle. But before you get into that, you'll notice that you have a 1z squared here. So anytime I have a 1z squared, I'm going to have z and z in our two parentheses. And then the question becomes, what numbers go in these spots? So what I'll do is I'll go off to the side, or I'll leave myself a good 3 or 4 lines here and think about the factors of the first times the last, so factors of 10, that are going to add up to negative 11. So again, what you'll do is you'll start with the 10 divided by 1, and you'll get 10, and you'll say, okay, can 1 and 10 sum up to negative 11? So if I have a negative 1 and a negative 10, that will give us the negative 11. Now, we want to make sure that that combination truly works. So if I take negative 1 times negative 10, that gives us the positive 10. And if I take negative 1 minus 10, that gives us the negative 11. So negative 10 and negative 1 does work as our combination. So we can plop those numbers down where we have negative 1 and negative 10. And then this is still equal to 0. So now we have a factored polynomial. And the great thing is we're trying to take this thing apart. So it's getting more and more taken apart here. Now we have 2 sets of parentheses. So we can set each of these factors equal to 0. So we're going to set the factors equal to 0. So we will have z minus 1 equal to 0. And then z minus 10 equal to 0. So I will add 1 to both sides, and that will give us z is equal to 1. And again, here is my both sides splitting up, and so I get that the negative 1's cancel, and then the 0 plus 1 gives us 1. Over here, again, here is my equal sign. That splits us up into two sides. So I'm going to add 10 to both sides, and that will give us z equals, these negative 10's of course cancel, the 0 plus 10 gives us 10. So we have z is equal to 10. So our two solutions, our solution set, will be 1, 10.